Welcome to this exercise where we're going to talk about fractions and working with fractions. So for this, I prepared 4 exercises, which is simply the same two fractions added, subtracted, multiplied, and divided with each other. Well, let's jump directly into it. Start with the first expression with 3/7 plus 1/6. So if I have something like this, and the same will apply to the part B as well. So if I have two fractions and I add or subtract them, the first thing I have to do is determine the common denominator or the smallest common denominator. Well, I said smallest, but if we want to make our lives a bit easier, just get a common denominator. So a denominator which can be divided by each of the two numbers. Here the easiest way always is multiply the two denominators, which in our situation would give a result of 42. And to get there, we can very easily just assume that we have a 1 standing here multiplied to the first fraction. Well, this does not change the result, and this 1 could be written as 6 divided by 6. Then I multiply the denominator with 6, giving me 42, but I will not change the result if I also multiply the nominator with the same 6. So what I did with 6 on the left fraction, I do with 7/7 on the right fraction. So multiply this with 7/7. Then I have a denominator of 42 as well. Since I changed the denominator by the same number, the result as such would not change. So it will look like this. Well, if I multiply two fractions, I multiply the nominator and denominator with the respective values from both fractions. So I go here 3 times the 6, 7 times the 6, and on the right part 1 times 7, 6 times 7. So I can calculate these two parts, giving me 18/42 plus 7/42. Then, since I have the same denominator in both fractions, I can just add the two nominators, giving me this result and 25 divided by 42. Well, now I could think about making this a bit smaller, but for this I would have common divisors with 25 and 42, which there are not, so I cannot simplify this expression anymore. So let's go instead to part B. Here I have the same expression as before, but instead of the plus, I have a minus. As I already hinted at in part A, calculation would be quite similar, because here I also need the common denominator. So I'm going to do exactly the same thing I did before in part A. Multiply the first with 6 divided by 6, the second with 7 divided by 7. Calculate this. Again, I have 18 by 42, 7 by 42, but instead of a plus, I have a minus here. Well, then I can just simply, since they're both having the same denominator, calculate 18 minus 7 in the nominator, giving me this, and thus 11 divided by 42. Again, there is no common divisor with 11 and 42, so I cannot simplify this fraction anymore, and this is my result for part B. Bringing me to part C, with first fraction multiplied with second fraction. And that's actually the easiest of the 3 standard calculation types, because in this regard, we've seen this before in A and B, I simply multiply the two parts above the fraction line, the two parts below the fraction line. So here I just go with 3 times 1 divided by 7 times 6, giving me 3 divided by 42. Since 42 is divisible by 3, I can simplify this a bit more, resulting in 1 divided by 14. But there is basically the end, so that's my end result for part C. Bringing me to the fourth and final part D, where I divide the first fraction by the second fraction. Here, you might recall the saying from school, if you divide by a fraction, it's the same as multiplying with the inverse. So I can change 3 by 7 divided by 1 by 6 to 3 divided by 7 multiplied with 6 divided by 1. So that's the inverse of 1/6, 6/1, so to speak. And then, well, I'm at a multiplication problem again, so I do exactly the same as before. I multiply 3 and 6, 7 and 1, giving me as a result 18 divided by 7. Here I can again see there is no common divisor with 18 and 7. So that's my final solution to part D. Well, this concludes not only part D, but also the full exercise. So I say goodbye and see you next time.